All right, welcome to our talk. So this will be as interactive as you want it to be. So all the code that we have for this talk is going to be completely open source, working examples. You can follow along. We'll provide links for everything and then kind of set up instructions on there. So really the point of this talk is scaling data security. This is something that, James and I both work for a company called Basis Theory. We do tokenization, data encryption. We deal a lot with customer data, have to secure, have to encrypt it to be able to support a wide variety of different use cases. So these are problems that we've had to actually solve, and these are things that we actually built internally to our product. And then after we started looking at this, we started saying, hey, this is a hard problem, right, to solve in most organizations and most systems. So we opted to just take all of that code and open source it. So we took a core part of our system and we actually put it out there so anybody here can grab that code, implement it, or use it as a pattern to go implement within your own organization. So that's kind of the basis for how we kind of got to this. So all this code is actually working in production environment with real production systems. This is actual picture. We went to Walmart a couple weeks ago, got this photo taken. So this is James and I. So my name's Brandon. I am the CTO at Basis Theory. A little bit about myself. So I actually got started in data security a really long time ago. I started off my career in the military. I did cryptography for the Air Force and worked heavily on cryptographic systems, network security, network infrastructure, that type of stuff. Did that for several years. Also got my master's in computer engineering, focused on data security, specifically in network security, information assurance, that type of stuff, focusing on encryption algorithms and that type of stuff. James and I, we actually kind of met about 12 years ago. We were both founding members at a small little fintech startup called Dwala. I think I was employee number 5 and James was employee number 6 or something like that. We started within a couple weeks of each other. I ended up going on, worked for a company that had high frequency trading on the New York Stock Exchange, on the Mercantile Exchange. So we did massive amounts of data volume through that system. And then I ended up going on working at John Deere for several years. So I was working on the team that took a lot of their systems to the cloud. So kind of an idea of what we were doing there is, if you think about a tractor or combine or something like that going through the field, hundreds of data points, 5 hertz, so 5 readings a second across every sub-inch accuracy, basically across all North America, South America, Europe, Southeast Asia, parts of Africa. We were processing hundreds of thousands of records per second, 24/7, 365 days a year. Claim to fame is when we went to AWS, we took down US East 1 multiple times, causing multiple wide-scale outages on the US coast, and I can go deeper into that. So that was a fun one. Worked for a Department of Defense contractor. They did things like satellite relay systems, missile defense systems. They had a spaceship that went to the International Space Station. And then before Basis Theory, I was an enterprise architect for a large Midwest retailer. We did pharmacy, payments, e-commerce, supply chain, a variety of other stuff. So kind of a storied history, working across a lot of different industries. But at the root of all of that is data security was a prevailing problem that we saw everywhere, right? It was consistently a problem. Didn't matter what industry you're in, didn't matter what compliance you dealt with, didn't matter what technology you were working on. This was a problem that we ran into over and over and over again, and it was hard to scale in organizations.
I'm James. So I spent, like Brandon said, I have a way less impressive resume as Brandon. So I spent time with him at Dwala, and then since then I spent a bunch of time in a bunch of large insurance companies doing both product and engineering consulting. So that means that when you're at companies like Allstate and these companies, they have all of this data spread across the entire organization, and they don't know how to secure it, they don't know how to use it. Then once they do secure it, they end up orphaning themselves off into into different business units, and they can't participate in a corporate data system. So like Brandon said, a lot of the experience that he has from the tech side and that I have from kind of the product and some engineering side, I think is coming together with what we're doing here, both at Basis Theory and with this talk for how we scale. So
awesome. So we have to do the de facto, a little bit about the company. Our marketing guy made us put this slide in, so I'll just do the little brief thing. So again, we do tokenization. So basically, on behalf of customers who don't want to deal with the compliance, don't want to deal with the risk themselves, basically the idea is like we basically house that information. We provide you back a token, a lot of attributes and properties around that data without ever decrypting the information and basically reducing your compliance and risk exposure as a whole. So. All right, so examples for this workshop, by the way, that QR code works. So if you want to use that, feel free to hold up your phone. You can scan it. It should open up a link directly to this GitHub repo. But if you also want to just go to our GitHub Base Theory Labs, encryption examples, by the way, we have several other examples out there of other things around our product and other things, but this one also will have everything that we're going to use here. Couple caveats for this talk. So the examples are all written in .NET Core. So if you're using a Mac-based device, you can just basically open up your terminal, type in brew install .NET, and that should basically run it. We also use Docker pretty extensively where we're at. So there'll be a few examples in here that run Docker, so that basically you can do the same thing, install Docker, and then basically we built everything to just do a simple make command as well. So we'll show all that. So you can just run one command, get all the examples up and running, and you should be in business. So. I'll give everyone a second if anybody wants to follow along. All right, everyone good? Anybody still need more time? All right, so James, you lay out the problem set that we're doing.
Yeah, so with this, like I think Brandon said, like a lot of the problems we've seen over the last decade and a half of being in both fintech industries and insurance and other large companies is as companies scale their problems, and it's not just technical problems, it's actually a lot from the business side of the organization, which drives developers to make decisions, which expands your system scope, which makes you split systems, which makes you, create more products inside your organization, which creates different sets of data. And with this example, like we really wanted to start with what's the simplest possible thing you could do, and then kind of walk everybody through like the progression of a company going from a startup all the way up through, hundreds of millions of dollars in revenue, and what a system scales and how your systems scale. And Brandon will go through all of the code and show you that. So the example that we're going to start with is, a company, is selling a product, and like this is very similar to what we did at Dwala, is they're going to take bank account information from all of their customers, and they're going to write an ACH file, and they're going to start processing payments. And when you start that, you never do the most safe thing, right? Because what you're trying to do at a startup is you're trying to get product market fit as fast as possible, right? You're trying to take people's money and give it to somebody else. You're not trying to necessarily solve all of the security problems that come along with building a fintech company. So yeah.
All right, awesome. So we're just going to jump right over real quick. I believe I should have my terminal open. All right, so in the encryption examples, if you're following along, and let me see if I can make this a little bit bigger. Maybe it's just, there we go. All right, we'll make this a little bit bigger. Can everyone see that? I'll try and go a little bigger there. Okay, so inside this example, there's a simple make command. So if you're running this, all the examples are basically make, and then if you tab, it'll do example, and you can go through each one of them. So for the first example, we're just going to use example 01. What this is going to do is it's going to start everything, it's going to build it, and our application is now running out here. So what we're going to come out here, and we're going to do is we're going to click on, I believe it's this one, and so we just got a really simple application here, right? So we're just going to prompt for the ability to come in here. We want to be able to capture some routing information, right? And we're just going to capture like a routing and account number. Pretty basic lifecycle, right? We just want to capture that data, right? We're just going to view this information in here, right? You can come in here, you can do normal stuff like viewing details, back to list. Like there's nothing really crazy about this application, but what we're trying to do here is we want to show like a really simple example, and then we're going to progressively show how like kind of that security gets more and more complex as you add in new requirements and new compliance and security requirements. So let's go take a look at the code real quick. So I'm just going to go ahead, close all these. We're going to jump over into the source, and we're going to take a look. By the way, I'll make this a little bit bigger as well. And we're just going to jump in. So there's nothing really complex about this. So if we take a look at our pages in here. All we're really doing is we're just pulling back, right, a connection to the database, and we're just saying, hey, I'm just going to go ahead and grab those records, and I'm just going to do a simple, like, take the record, save it. If I'm viewing details in here, all I'm really doing in here is I'm just pulling back the records directly from the database, and I'm just literally taking them and displaying them on the page. I'm not doing anything fancy in here, right? It's just straight up display the routing number, display the account number. Like, there's nothing in here. Like, we're not doing any data security, we're not doing any encryption in here. And I think most of us have probably worked at organizations, whether it's PII data, bank account data, sometimes I even ran across like credit card data, right? And you ran across and like the data is just sitting in plain text. And what you typically end up seeing is like pull the data directly from a database and then just display it on a form, or pull it directly into some sort of app and process it. No security, no, right? And then, right, and we've all been at other organizations where it's like, hey, you know, Bob needs access to the database because they're trying to debug something, or hey, my system needs a copy of that data for whatever reason. And guess what? Copies and copies and copies of that data get floated around, and it's all now sitting in plain text, and now that information is out there. By the way, we've been in situations on calls where we've seen like lots of plain text, highly sensitive data just being displayed on screens before, and right, not a lot of you know, data sanitation, not a lot of data protection going on in that. This is what I've typically seen in my career going into organizations, is no security around any of that sensitive data. Really, the only driver we've seen around security has been when there's been a compliance factor that has demanded it, right? So like a PCI coming in and saying, you must meet PCI requirements, here are the requirements, you must vault your data, you must isolate your information, right? Other than that, a lot of your other highly sensitive data, and by the way, this doesn't have to be bank data, it could be things like pricing information for your organization, it could be invoicing data, it could be customer information. That type of stuff gets ignored. So one other thing, like, and I'll give kind of a thing that I've seen in the past too, is because some of the data security stuff is so difficult that companies deal with, but I was at an organization once before, I remember coming across a database table, it had every single employee piece of information in that table in plain text, including things like address information, social security numbers, email, phone number, all sorts of other stuff. I remember basically going to the CISO and saying, hey, there's a problem here, I found this data, file a ticket, goes into the risk register. 2 years later, hey, data's still sitting there in plain text. By the way, I'm taking this personally because my information's in that same table with it, right? And because you come back to it, it's like, well, yeah, that's a problem, right? But where does that fit in the priority of everything else we have? They accept the risk. And so like what we're gonna do is we're gonna kind of, through these examples, we're gonna show why this is so hard, why engineers kind of go into the spot and they don't choose the path of actually taking on security because it makes it difficult. And then we're gonna pull everything back together and show how you can do this really simply with basically how we solved that problem.
Yeah. And like keep in mind too, as we go to the next example, is like the people that are implementing this aren't like trying to do the wrong thing, right? Like they're having the same problems as every engineer, right? The business demands or the product team demands that we move fast, or there's a problem that we need to go debug, and the only way the engineers doing it are like, hey, it'd be way easier if this data wasn't encrypted, right? So they just make that decision, and it's not because they're trying to do the wrong things, it's because they're actually just trying to get their jobs done, right? So a lot of these problems, like the problem Brandon's explaining, like once you get into the corporate level, like those are slightly different problems, but like early stage companies, they're not trying to build the wrong thing first. They just don't have the tool sets available to them a lot of times to make their day-to-day jobs easy. So they make choices like this, which really put their customers at risk, the data at risk, and the organization ultimately at risk. So.
Awesome.
So now, as this business is kind of growing, right? Like the Notcha just, over the last 2 to 4 years has started to roll out this new framework for how to protect banking information, and they're starting to pull things in that are similar to the PCI standards. They're nowhere near as strict around networking and things like that, but they've started to demand that you either encrypt, tokenize, desensitize, or fully redact and delete any banking information out of your system. And a lot of this happens as businesses scale. Like the first startup business, Notcha doesn't care about businesses that are doing small amounts of data. Once you get into the millions of data records and you're moving millions of dollars of money on the ACH network, that's when Notch starts to care. So as this business is starting to scale, we come to Brandon and we're like, hey, Brandon, Notch just rolled out these new things. We got to go and build out this new encryption for the data that we have today. And again, keep in mind, up to this point, the developers have been doing the things that they need to do their jobs, right? So now we're going back and saying, hey, we're about ready to make your job harder because of this new regulation. It has nothing to do with our business, right? It's not going to make us more money. It's not going to help us move into a new market. It's just to protect ourselves from getting audited and potentially not being able to participate in the ACH network.
Awesome. All right, great. Let's jump into the example number 2. So this is where we're going to start actually implementing a little bit of the data security pieces in here. So I'm going to jump in here. So by the way, one thing you're going to quickly notice in here is now all of a sudden we have to create net new models, right? We're having to add all this extra boilerplate into our code, right? Because now we have to start building abstraction layers between the data that's now that's encrypted, sitting secure within our database, to what we actually are allowed to display back on the screen, right? So now we're having to build abstraction layers around creating the data and mapping it, and then also reading the data back out. And really, I wanted to dive into a couple things. So the first thing you're going to notice in here, and let's just go look at the details because I think this will be a little bit more inclusive, is one thing that now we have to end up doing is now we have to call this Encryption Service. And because the problem that we run into is now all of our data is actually sitting encrypted in the database. Now we need to encrypt and decrypt it every time we interact with that information. So we don't want to have to bleed that throughout all of our application. So we're going to try and abstract that away as much as possible. So now we've added all this extra code in here. So the first thing we're going to do is hey, when I'm reading it back, right, I'm just going to call this service. I'm going to say decrypt the routing number, decrypt the account number before I end up displaying it back to the customer. Or if I'm creating it, I also, on the other side, I also need to encrypt the data before I write it directly to the database, right? So we're adding this extra abstraction layer in here. And really, there's nothing too complex about that. In this example in here, we're just literally, most of us have seen this pattern before as well. I'm actually going to go read just a hard-coded encryption key that's literally sitting in a configuration file somewhere, right? And I'm going to end up pulling that back out. And then what's going to be great about that is then really I'm going to read that key in, I'm going to configure the service, and I'm just using a simple AES encryption decryption in here. There's nothing too crazy about that. The only nuance that I wanted to call out here is that you don't typically want to use the same initialization vector across multiple AES encryptions, right? So you would typically want that initialization vector to be different. So in that situation, right, we need some way to essentially store off that IV associated with the ciphertext as well. So that's the only nuance to this code specifically. So this is kind of starts to show a problem though, right? So if you notice that encryption key is sitting in a configuration file. I'll tell another story from the trenches is, guess what typically happens at every organization I've been at? Hey, I need to debug something, and somebody grabs that configuration file sitting on a server somewhere, right, or gets injected in a Docker container, and then that gets passed around throughout the organization. Now all of a sudden, all your engineers have production database access, they have access to the encryption keys, they have access to all that sensitive data. The other problem too is with having that, and we'll kind of show a little bit around some of these pros and cons, you still have a static encryption key, right? So the second that key gets compromised, well, guess what? You're going back and having to re-encrypt all your data. Once we get into multiple systems that need to be able to access that information, this is another problem I've seen, is let's say James works on a different part of the organization, he needs access to that data. Well, what happens in every single enterprise I've been at is, okay, you need a copy of that data, so what I'm going to do is I'm going to decrypt all that information because that encryption logic and key is proprietary to my application. I'm going to decrypt it, put it into some sort of CSV file, ship it to you, and then you're going to implement it within your system. And so that's basically how data sharing happens in a lot of big enterprises. Well, you're only as secure as the least secure copy of that data. So eventually down that chain, as there's going to be some developer under another tight time constraint who's not going to encrypt that data, they're going to shove it directly into their database table or their collection, and they're not going to do proper data security or sanitization. But some nice pros about this thing. Like if you're working on a really, really basic, simple system, right, this isn't necessarily a bad solution, right? There's a lot of turnkey solutions out there that can be solved, right? If you notice, like a lot of your frameworks out there, web, like whether it's, .NET or Java, or if you're using Node or something like that, there's like built-in solutions for a lot of like your really basic encryption. Implementation's usually pretty simple, and AES doing that simple solution is pretty fast compared to most like asymmetric encryption patterns. So it's not necessarily a bad overall solution, but we'll show kind of where that starts to break down over time.
Yeah. And again, like if you think about what the business side of the organization was bringing to the engineers, it was not revenue. It was, we got to go do this thing, like make it go away, right? So all those pros in that list are literally what the business cares about. They don't care about the right side of the the con list at all, right? Because again, like we're not going to go make more money doing this, right?
All right.
Yeah. So the next, so now we're more secure because of compliance, right? We're getting better. We're maturing as an organization, and now what we're saying is, hey, like the business needs to grow. We need to grow, add a new business line. We need to go start doing another process with this data that we have, right? We need to go either put it into another system or we need to move it to another place, right? So when you do that, right, like you start to create additional systems. So the business problem we're bringing to the organization is, look, if we go spin up this new business line, we're actually going to go capture more money, right? So now we're again, like we need to move as fast as we can into this new market, right? And this new market is going to cause us to split our systems because we can't have two separate business unit teams working in the same code base all the time, trying to execute on different goals, right? They're just going to step on each other. They're going to create a bunch of problems. So, so that's kind of where we're leading to, right? Like the business is just saying, hey, we got to go spin up this new feature, this new product. Help us go and kind of expand this. And by the way, we need to use the data that you're now encrypting in both of those two systems.
So when we started looking at the different options of what we could implement, and really, again, most of these things are usually time sensitive, right? The business is like, how do I go fast, right? We want our feature now. We want to be able to move quickly. And so we started looking at it. It's like, well, what the right approach probably is, especially when you're exposing data to multiple actors, is probably to put it behind an API, right? Because you should have a single actor on that data anyways. But really the problem though is that you end up having to re-architect a lot of your system though, right? Because now all of a sudden I'm switching away from making a database call to something now I have to make an API call, and now I'm dealing with things like, well, I have to do message correlation with correlation IDs, or I have to do retries and error handling and all validation, and I have to add authentication, authorization, and all sorts of other stuff, right? So now there's this additional overhead if we went with the API approach. Well, I don't think that's going to fit in the scope of this solution. So the other thing that we looked at was like, well, maybe we could just take the encryption key, right? Because we have it in one system, and let's just copy the encryption key to the second system, right? That's a pretty simple solution. But now again, you have the problem of now, what do you do if all of a sudden you have to like change that encryption key? Now you have to know the life cycle of every single system, every single spot that key's in, to make sure you go update all of them and that you do it at the same time. So we thought, well, that's not exactly the best solution either. So then there's a common tool out there that's available specifically for key management, and that's called a key management service. Every major cloud provider has this, right? So AWS has KMS, Azure has Key Vault, Google Cloud has CMK. There's also other like off-the-shelf solutions, like if you can use HashiCorp Vault and a bunch of other tools out there. So we're going to opt to go with a key management service because it just provides, without making big changes to our code, we just want to basically provide access to that encryption key so that way we can encrypt and decrypt without necessarily having to inject that encryption key into multiple services.
And keep in mind, like a lot of times that config file that Brandon showed, they'll actually pick the second bullet because all they have to do is copy that thing into their new system, right? A lot of times businesses will choose to do that, especially at the corporate enterprise level. They're saying, oh, you already solved this problem. I'm just going to copy paste that into my system, right? There's a pattern for it. Right?
Yep.
And not think about the scalability, not think about the architecture.
So if you notice in here, we're essentially, now we've split this code, right? So we've got our main customer portal and then the main bank processor that's going to be doing the ACH file generation. And hopefully this isn't like too technical. Hopefully most people here are semi-familiar with Docker. But what we're going to do is we're going to spin up basically two Docker containers. One's for our customer portal, The other one's for our bank processor, and we're just going to opt to go with a really simple emulator. So we're just going to choose in this example Azure Key Vault, just because we want to be able to demonstrate, one of the major KMSs out there. So we're going to load this up, and then we're going to basically read and write all of our keys directly to Azure Key Vault. So in this example in here, I'm just going to open up, and we're going to go back into that encryption service. I think this is the same service we're going to go back to quite a bit throughout this example, and we're going to kind of show. So in here, you're going to notice we're pulling in Azure-specific key client and using the same encrypt and decrypt. So none of the rest of our code is changing at all. We're still using the encryption service, still using all of that type of stuff, and all we're really doing is taking in that plain text. We're using Azure's Key Vault in here, and we're just going to go ahead and encrypt the data, and then we're also going to use their crypto client, and we're just going to decrypt, right? So again, none of the rest of our code had to change at all. Like, we're still able, if we come, we'll just go take a look real quick at our customer portal. We're going to go look at our pages, and we're going to take a look at, let's say, the details one. And notice in here, this code remains the exact same as what we had before. So we didn't have to make any changes. Yeah, go ahead.
So I don't know if it's time for question or if this is out of scope, but first of all, what you're describing is 100% the journey that I've seen going through many companies. There's one thing that you're not covering here, maybe that's out of scope, but if you start with the data encrypted in one way and you're kind of moving through the chain of adopting new encryption systems, there's a data migration element of it that you're going to have to factor, and usually it comes with, hey, now I need to go through a data migration process that will take my app down for X amount of time, and then I need to factor in, and that's usually when product and business will be like, we can't do that. So, again, you may not have the answer to that, but I'm curious if you have experienced that, and what would be ways that you would address that with your...
Yeah, and I was going to hold that exact problem for the end, because that data migration is kind of like one of the what happens if type thing. So the strategy I've typically used in an organization is what I refer does everyone know what a surrogate property is, or a surrogate column is in a system? So a surrogate basically allows you to say I'm kind of aliasing this other solution. So what that allows you to essentially do is, in typical data migration problems when you're trying to go from one structure to a different structure while not taking any downtime through that, is what you'll end up doing is basically have two columns in your database, right, in that example. And so you might have the old pattern and the new pattern in that format. And by the way, the final solution we're going to show is how you can alleviate that, so you can make the changes without having to do any of this. But you'll end up basically having your old column and your new column, and then you create a surrogate column or property within your code that says, hey, I'm going to try and read from the new. If it's not in the new, then I'm going to try and reference the old. Because what you're trying to do is essentially build that abstraction layer through your data model so it doesn't bleed through the rest of your application. So you're essentially doing a dual read, but then you're only doing basically the write to the new one, right? Because you want to slowly migrate over time. And then you can run that migration asynchronously from the rest of it without eating any of that downtime. That's a pretty common pattern for any form of migration where you're going from, let's say, I'm changing the structure of the column, I'm changing the length of a column, right? I need to rewrite my data, right? A good example is rehashing or something like that. Pretty common pattern without eating an outage. So,
and I mean, your question is perfect, because I think what happens a lot of times is what Brandon's showing is the engineering side of the organization goes and says, hey, we're going to do this key vault thing. We're going to go do all this stuff, and oh, by the way, we're going to have to eat an outage. And then the product managers are like, absolutely not. And then what they do is they go back and they copy that configuration file and put the key in the second place and say, problem solved. Right? Problem solved. We didn't make anything any more secure. We didn't solve any other problems, but problem solved, right? And the product people think, oh, it must be just as secure as the solution they were going to pick, because why would they have suggested it if it was any different, right? So this again is where the hurdle of data encryption. It's not about the business pushing. It's not about the engineers making the wrong choice. It's that the tooling is hard to use. We're making the wrong choices up front. Right, and then when you need to do the data migration, your question's valid, right? What happens, right? You can do what Brandon said, but a lot of times they just choose not to do that. Cool, we'll just get it done in 5 minutes and just copy this key over, right?
Yep. Awesome. So we'll kind of talk about some pros and cons of the KMS solution. So one, obviously a major pro of this is you're not exposing those keys out to multiple systems, right? You're trying to find a central place to manage those keys and house it. In this example that we showed before, our keys are still static, right? Usually best practices when you're dealing with any form of encryption key is you want to do key rotation. And essentially what key rotation means is there's two different approaches to that. There's one, I need to rotate my key and re-encrypt all my data, right? And some people think of key rotation as being that. The other and probably more common and better solution is dealing more of a time-based or some sort of frequency-based key rotation. What that basically means is I have a set of data for a period of time encrypted with one key, and then basically at some point I'm going to change that key, so then the next period of time is encrypted with another key. After a period of time, then I'm going to change the key and encrypt it. So if any one of those keys gets compromised, only a subset of your data is compromised and not all of your data. Now, obviously, that's not universal to everybody. In some large organizations, they typically require you to at least rotate some sort of like master key or something like that periodically. So then you started getting into things like data wrapping and things like that, which can help with some of that. But this is typically what you'll end up seeing when I talk about key rotation. The other problem that comes with this, if you notice in that example, is there's no native framework integration typically for your common KMS. You're typically hand rolling some sort of custom code that's boutique to your solution to go implement with any form of KMS you choose, right? So if we go back to the example here and we go look at our encryption service, I'm not using anything in here that's specific to, in this example, .NET, right? And this could be Java, it could be something else. I'm actually using a library, right, directly coming from Azure, right? And whether we're using AWS or Google Cloud or HashiCorp, right, you're probably using their SDK, their libraries, interacting directly with their stuff. So now I'm bleeding to my business code, within my application, I'm bleeding proprietary implementation that's specific to my app, to that integration, right? And so now what do? All of a sudden, I run into a situation where, hey, like, we're going to the cloud, right? Everybody in the last 10 years has probably been an organization like, we're going to the cloud. That's the new technology strategy. It solves all of our problems, right? Or, hey, we're hybrid cloud, right? Or multi-cloud, right? Large, especially most of us working probably in fintech. Most of us are probably multi-cloud or hybrid cloud type solutions, right? What if you have an on-prem, right? I'm using HashiCorp Vault on-prem and I'm using, let's say, AWS KMS in the cloud, right? How do I start solving that within my code when I need to be able to run in multiple environments, right? What do I do if I need to run locally, right, versus running in a deployed environment, right? So like it starts introducing a lot of complexity in the code that you typically don't want to have to deal with as you're implementing your own solution. So all of a sudden, CISO comes along and that key rotation policy we've been holding off on, right, that we haven't done, now they're requiring us to do this.
That's right. And I mean, like Brandon said, like the implementation we have now, right, is very specific to a single organization. It's very specific to Azure, right? And I don't know how many people here have actually worked at a large organization, but literally none of those organizations say, we're going to go to AWS. They say, we're going to go to the cloud, and that means we're going to go to all of them, right? Which is, if anybody's ever tried to go to more than one cloud provider, it's like an impossible feat for the smallest companies. It's clearly impossible for the companies that are copying configuration files around to do their encryption, right? So now you're stuck with the solution that you have. You're stuck with Azure. You have no way out of that possibility because, like Brandon said, it's baked into each one of your applications, right? The security posture is baked in. The direct integration into Azure is baked in. And now your business is coming in saying, hey, by the way, we need to rotate these things. We need to be thinking about going to multi-cloud. We need to be thinking about all these problems. And the developer's like, well, like, hey, like we're just copying keys around right now. Or, hey, like now we're gonna have a direct integration with Azure, right? So now when the CISO comes and wants you to like support multiple KMSs or support multiple keys and rotations, you're dealing with direct, very specific boutique integrations like Brandon said. And again, like these things don't always relate back to revenue, right? The size of the company we're at now, right? This is probably a hundreds of millions of dollars. So they probably have a brand that they need to protect, right? When I was at Allstate, all the decisions that they made were to protect that brand, right? They were very risk adverse because the brand of Allstate was the most important thing to them. It had nothing to do with, they would choose not to make innovation choices. They'd choose not to build features because they couldn't protect the data, right? They couldn't get it to the subsidiaries. They couldn't make these choices, right? And it wasn't because the technologists couldn't do it is because the business was too afraid to lose their brand, right? So again, like these decisions aren't necessarily always about making more money or even saving money. A lot of times it's either being risk adverse because of their brand or because, again, like a CISO posture for SOC 2 or another compliance reason or ISO, right? They're coming to you and saying, hey, we need to implement this and turn your roadmap off for 6 months, right? Or 2 years, depending on the size of the organization.
So other examples I've seen where this type of stuff gets pushed. Last company I was at, we were 3 different environments that our systems ran in. We were Google Cloud, we were on Azure, and we had on-prem with OpenStack, and we had to support key management in all 3 environments because we were accessing common data sets between all of them. So we had to try solving that there. When I was at John Deere, that was a very unique problem because not only did we have an on-prem presence there, because the reason why we went to AWS is we physically ran out of space in the data center. Like they could not find room for more servers because we were processing so much data. So then that's why we went to AWS. But at the same time that we were going to AWS, that's when all the GDPR regulations came out. And because we were an international organization, now all of a sudden we had data presence in the US, EU, right, India, parts of like China, right? And China has really strict data residency requirements. We have South America, Brazil has really strict data residency requirements. So now all of a sudden our data had to be able to reference different key management services, right? And different encryption keys that were in all these different geographic regions. So now we're trying to solve that problem in addition to how do we then move to the cloud with all of this at the same time. So we're going to kind of jump into this next example. We're going to kind of show how we solved it and really where this starts to break down this solution overall. So I'm going to come into our 4th example. We're just going to go directly back into the same thing we've shown before, right? This encryption service. So again, we've made no changes to anywhere else within our application. The only thing we've changed in here was this encryption service to meet the requirement. But there's one big problem here. So when we come in here, what we're going to end up doing is we're going to just set on our key. We're just for the sake of entertainment, we're just going to set the expiration be for an hour, right? That's all we want to do is just say expired after an hour. So that way we're just every hour rotating the key. But there's one big problem in here though, is that now all of a sudden that key ID, right? I need to be able to track specifically what key and what version of that key I encrypted the data with. So when I come back, I can decrypt it. So now all of a sudden we have a very proprietary thing where we're taking that key ID that's very specific in this example to Azure, and we're coming up with our own format of how do we store that along with the ciphertext. So when I read back, I can say, hey, I'm going to go split it. I'm going to grab the key ID. I'm going to go generate my client so I know I can decrypt with that version of the key, right? And this doesn't even account for things like what algorithm did I use, right? And I think you brought up that question. It was like, well, hey, what if your encryption thing does? Well, RSA really only supports up to the number of bits of your key size. If all of a sudden we get asked to go encrypt, let's say, a document or a larger thing that exceeds, let's say, 2048 or 4096 in bits, well, guess what? This entire solution breaks down instantly. And now all of a sudden we have to start thinking about wrapping our data, right, with an AES, an RSA, or double AES or something like that. And things start to break down pretty quickly because this pattern doesn't scale to other KMSs and it doesn't scale to other encryption algorithms and encryption strategies. So you can start to see the complexities start to really bleed into the system and the questions start coming up that now, right, you were saying, hey, what do we do about the migration? Well, each one of these examples requires us to create a new migration. And if all of a sudden we start dealing with data residency, we start dealing with algorithm changes, key size changes, et cetera, right? Well, guess what? Like now we're introducing yet another migration every time those things change. So to sum it up, doing this is really hard. Right? I mean, honestly, this is really hard. So Adam, who's sitting up here in the front, like he was the first developer we hired full-time when we started Basis Theory. Him and I actually worked together at another company. And we knew from day one, like encryption was the heart of our product. At the end of the day, right, our product with tokenization at the heart of it, like the tokens is important, but securing that data and being able to encrypt data on behalf of lots of customers bring your own encryption key, different key algorithms, key sizes, key rotation policies, all of those things drove us to build a solution that was highly flexible and wasn't very contextual to a specific business problem. Like we had to build something that could be used for a variety of different use cases. Like, because we have some customers who are like, hey, we don't want to use Azure Key Vault. We don't want to use AWS KMS. We want to use our own encryption key, right? For like enterprise key management. Hey, we have another one. It's like, hey, our requirements is you have to encrypt with a very specific algorithm, a very specific key size, right? So instead of using AWS GCM, you have to use CBC with a very specific thing. Like, how do you solve for all those types of problems and do that in a dynamic way without, again, going back to my code and making that change all over the place that requires to constantly go back and make churn on that. So we spent a lot of time early on building a solution that would scale with the organization. And the best part is we don't touch that code. Like it just works, right? And so I wanted to show our approach to how we can adapt to that without making any code changes. And this is the solution that we pulled out, we open source, and again, this is available. You don't have to use this within your own environment, but we're trying to lay the blueprint around how you should think about this and how you should be thinking about implementing this within your own systems. So why is encryption hard? Again, security is not static, right? I think a lot of us think like, oh, it's just a key, I'm just encrypting, I'm just decrypting, right? A lot of us think that. But if you look at this, we had 3 different things that changed our approach to security. The first one was a compliance change, right? We all remember the Notch example, the very first one, right? That's a real example, by the way. I think Notch's requirements went in a couple months ago, and they pushed that out, and we had a lot of companies reach out and it's like, how do we comply with the new requirements, right? So that's a real example. Scaling an organization is a real example. We've all been in organizations that have gone from monolith to microservice architecture, right? Or have gone from on-prem to cloud, or have had to go to multi-cloud or hybrid cloud, or deal with data residency. We've all been there, right? So again, the business requirements change around how the architectural thing. And the last thing is the security requirements change. Our CISOs, like most of us deal with either like a security engineer, an app security engineer, a CISO, somebody like that, who will typically come in and be like, hey, new PCI requirements. I think PCI v4 comes out next year and is a hard requirement by 2025, I believe. ISO requirements, SOC 2 requirements, SOX, right, Sarbanes-Oxley. A lot of these things all have different compliance requirements around how you handle data, how you secure that data, how you access that data, how do you audit that data. A lot of that starts to come in and starts bleeding itself into all the applications and systems we work on. The other thing I wanted to call it is this is not a core specialty of most developers. Now, I know probably the fact that you're sitting in this room means you care about your career, right? The fact that you're invested in that and to come to a conference probably means that you care. But I think most of us can think back over the last 10, 15, 20 years, and we can look at what the average, engineer is out there. Most of them aren't security experts. Most of them don't know which encryption algorithm to use, which key size to use, what to do with those keys. Most of the engineers I've worked with don't even think and don't even ask the question of should I secure this or not secure this. They don't think about proper data sanitization or data sharing practices. Most of them just don't think about that. They're just thinking about, hey, the product manager told me I gotta go deliver this feature. What's the fastest way I can deliver the feature so I can get the next feature, right? And we've all been there, right? We've all worked with developers. It's not a bad thing, right? But the reality is it's just not a core specialty of most engineers. So why do we try and re-implement and rebuild that wheel? Every single system we work on, every single organization we've been at. And I think the last thing in here is most businesses typically take a good enough approach to software development. I can tell you, and for every developer here can resonate with, the number one complaint I've heard from every single engineering team I've been on in the last 15 years, not enough time for tech debt. Guaranteed, we can all relate to that. And security is no different. This doesn't feel secure. Yeah, but it's good enough. The risk is good enough, right? We're willing to accept the risk. And security kind of falls into that tech debt bucket of we're just not given the time to go fix these things. We're just not given the time to do things right. And I think the best part is, and why we've started to see stuff like OpenID Connect, JSON Web Tokens with OAuth, starting to see things like common logging patterns, common dealing with like ORMs, is it helps us get to market faster because it provides that abstraction, it provides that communication layer that interacts with third-party dependencies. But I don't see that same solution arriving in the security world, right? We don't have that. It's always, every system I'm on is a roll your own encryption decryption solution, right? Good. So we want to actually start digging into how do we solve this problem. So most of us know what JSON Web Tokens are, right? Like we know there's a header, there's a body, and there's typically some sort of signature on the end of a JWT. And most people, though, don't realize that there's actually another spec out there called JSON Web Encryption, right? And there's actually a defined thing. It basically contains a ciphertext. It's a standardized format for key information, and it looks just like a JWT, and most of your common JWT libraries will support this out of the box, meaning that you don't have to go and hand rule some sort of custom key or token creation and read and write from that token. And I'm just going to show real quick that. So let's go over here to this. So there's actually an RFC out here on this, and if all of you want some good nighttime reading, it's fun to go and dig in and read all of this. But again, they specifically come in here, and if you notice a lot of the things like key type, algorithm, key ID, a lot of these, if you've worked with JWTs in the past, these types of little acronyms are probably going to be familiar to you. And so the nice thing with this approach is by using this implementation is that now we can start, instead of us defining what our key implementation, our ciphertext needs to look like, this allows us to follow a standard format. So that way when we come in and we say, hey, we need to store this in the database and we need to read this back out, it has all the pieces that then we can plug in different key management solutions, different encryption algorithms, and we don't have to go back and re-change our structure around how we handle that data. And by the way, we have the implementation for all of this in the open source library, which we'll show here. And there's also some parameters in here specifically what the structure of that key data needs to look like.
And like one thing to keep in mind too, like as Brandon shows these, different standards, is we all deal with standards all day. Like think about the patterns used when you abstract software, right? You're using builder patterns. You're using these things that are relevant to making software better, right? Like when's the last time you worried about data in transit? Right? You don't, because HTTPS solves that, right? So now it's like, why are we reinventing data encryption at rest every single time we do it, right? Like these standards exist for a reason. It's time, right? Like what Brandon's showing next is like, it's time to start taking that seriously, because now like we should never worry about that again, right? People shouldn't be worried, just like HTTPS solves, right? Like we shouldn't be worried about data at rest in the same way.
Yep. So the next thing that we have to think about is like, but then ultimately, a lot of us have worked in an organization that deal with different types of keys across different types of encryption algorithms. There's actually a specification out there called the Key Management Interoperability Protocol. It's a mouthful, or shortened down to KMIP. So again, this is another really, really fun read. As you can see, there's a lot of stuff here. I'd recommend blocking off a week or two to really dig into this. But they actually define specifically what that key needs to look like, what attributes you need to track, specifically what the key structure needs to look like, and the operations you should be working with when you're dealing with things like encrypt, decrypt, create key, rotate key, etc. Right? So they've sort of defined that for us. And this is something actually, HashiCorp Vault actually has a native built-in KMIP implementation they've built within HashiCorp Vault. A lot of the other KMSs don't have that built in out of the box, right? So that was something that we took on, right? We said, hey, we actually need to provide that abstraction layer so people can get going quickly or see what this looks like from an actual implementation. So that way you have a blueprint you can follow. If let's say you're using Node or your Ruby shop or something like that, at least you can translate the code over to your specific implementation so we can start kind of tying all of this stuff together. Because that's the other thing we noticed when we started digging into this. There's not a lot of examples out here in any framework we saw. It's like, install the KMIP SDK and off to the races, right? It's not like with JSON Web Tokens, OpenID Connect, et cetera, where you just install the library, plug in a piece of middleware, and you go, right? So somebody had to be the first to go build that. We took on that effort, at least for our implementation. So we decided to combine both. Again, we tried to pull all these pieces together. So what we tried to do with this is we tried to basically come up with a structure specifically around how do we actually combine these two pieces together? How do we ultimately abstract away all of that details around configuring encryption, setting it all up, and removing that barrier for engineers to get started with actually interacting and doing data security. So we built something, it's called, we just coined it Kms Sdk. Again, all the code is open source out here. So if you go to basically OpenKMS, the code's here, you can follow along, you can play with it, and you can use this and implement this within your own environment if you want to, or you can abstract this and build this for whatever stack you're in. And so the nice thing with this is we decided to build support for a variety of different key providers out there, or KMS providers, so things like AWS KMS or an Azure Key Vault and that. We also have built in on all of this key rotation, so it's basically set up through options that you can do that. And then really what we're trying to do is we're trying to combine this, so that way if I go from system A to system B and they both happen or need to read from that data, or if I need to take that JWE and export it and move it to another, I'm not having to decrypt my data, re-encrypt it in the second system. I can just hand somebody that, and if they're implementing this specification, they should be able to decrypt it there. So I'm not eating that decrypt and re-encrypt hurdle when I need to share data across multiple systems. I can just share that JWE with it. All right, so we're going to spend the rest of the time digging into specifically the solution and how we approached it. Any questions up till now? All right, let's dig in specifically the example in here. So I'm going to jump in here, and we're going to show that same example that we had before. So one thing I wanted to really call out in here, and you're going to notice a very drastic change between what we had before and what we have now. Notice in here, we don't have any explicit calls to some sort of encryption service anymore. Like we removed all that. We don't need that anymore for this example. So now we're just straight up reading from our database and mapping it to a model, and we then can display that plain text routing and account number on the screen, which is a pretty nice change from not bleeding that complexity throughout the rest of your system. And really what we tried to do, moving towards that, is the way we tried to handle that is implementing basically an annotation on our data model that says, hey, I need to encrypt this data, right? I just want to say encrypted and specify that there. But you're going to notice something really interesting in here is this concept of schemes. So I think if you've worked with like OpenID Connect or OAuth or any of that in the past, you're probably familiar with the concept of like registering schemes, right? To say, I want to use like this audience or this provider or something like that to be able to register multiple schemes. So we'll just kind of show what that looks like in a lot of systems. So if I come in here, I'll just come down into this, and let's go ahead and we're going to add a simple Docker or package in here, and let's just do bear. I think that's Microsoft Authentication Bearer. And we'll just install this real quick. We're just going to show what this looks like to wire this up in a common system. So if you were to do this in most applications, and I did builder.add, I think it's add authentication. Right, I believe it should pull that in. Let me just grab this. We'll install this. What is it, Adam? Is it add authentication or use authentication? Anyways, well, Adam's looking that up for me to help me out there. So one thing that we started looking at is how do I register without having that concept of all that encryption, key management, key options bleed throughout the rest of my application. Like I didn't want to have to go in and be like, when a CISO comes in and says, hey, what algorithm are you using? What keys are you using? What key size are you using? What's your key rotation policy? I didn't want to have to go and like dig through a lot of different systems to go look that up. So the way that we handled that in here is if you look in here, basically when you're building it, the driver that we tried to do is we tried to centralize all that key management and encryption logic in one spot. And so in here, if you notice when we say, hey, I'm going to add a scheme, right? So it's like our really great names, like builders that build builders, right? Which is a great one. But essentially what we're trying to do in here is it allows you to specify your different options in here. So you can just simply say, I want to add a scheme. I want to define specifically what I want to use for my content encryption or potentially key encryption. And you can literally just come in here and define like algorithms. So if I want to change on this one, like the key size, right? And I can do key size, I can just come in here and say, I want to do 512, right? And I can just change that key size automatically. And you can define that at the schema. So what we're aiming to do is we're trying to think about like what's the pattern engineers are typically already using today. And most of us are probably registering things like your logging framework or your authentication and authorization, all that. And you're typically doing it through some sort of middleware that's like at some sort of startup configuration. We didn't want to run the situation where now I'm inside of all my different services and I'm going through and be like, I've hard coded or I'm having to do the lookup for all these settings and all these other places. I wanted to centralize that in one spot. So with doing this is I can register in here and notice I've got multiple policies that I've registered in here, right? And they all have different options. And I can dynamically reference any of those policies for my encryption anywhere within my system. So if you have a variety of different options and you can change these things dynamically and your system will continue to work. So you're not eating, I think back to your question is like, hey, how do I change the pattern I use, right? And I don't want to have to eat an outage. I don't want to have to deal with a database migration because I've changed my approach to the security. This allows you to do that because all you could do is say, I'm either registering a new policy in here, right, a new schema with exactly what options I need, or I just come in here and I say, hey, I just come in here and I'm just going to change the key size to something else, right? Or if I want to change the algorithm down here, right, to something else, right, I can do that without necessarily having to go in and change the rest of my encrypted data. Because again, all that information is stored inside that JWE, right? So when I come back and decrypt later on, I don't need reference back to the policy anymore. Right? That in ciphertext, that encrypted data becomes self-referential at that point.
How do you pass that JWE?
What's that?
How do you pass it, like to the consumer? Like how do you, like is it attached to the request? Is it attached to?
Yeah. So are you talking about, like what do you mean by pass it to the consumer?
You obviously need to access the definition of that JWE somewhere, right? So I understand that you're configuring it on your application level, but the client is going to pass it to you to be able to say, here's what I'm passing to them, expecting you to break out and read.
Yeah. So on the other side, if somebody needs to be able to decrypt it, the only thing that they're required to have is actually register the actual encryption handlers. And I'll dig into the code for that as well. So let's take a look specifically at the solution that we have in here. So the way that we've set this up in here is we have basically this encryption service. And the encryption service is pretty straightforward. We're just basically building this JWE in here, right? And we're just making calls to these different handlers, right? We just need to make calls to say, I need to go encrypt or decrypt. But notice on here, when we say I'm going to decrypt in here, all we're really doing is on that handle, we're saying, hey, I just need to pull back an appropriate handler so that way I can go decrypt the payload and get this back out. You don't need to implement this yourself. Like this is all built into the library itself. So as long as that they've registered those handlers on the receiver side to say, hey, I've got the handler that actually knows how to decrypt it, you shouldn't need to make any changes. Like I could just pass that JWE directly.
But is it going in your HTTP request or is it like?
No, yeah, and I'll show exactly where we actually store that information. So let's just go open up a connection to our database and let's just go take a look real quick at that. So I believe I've got, let me go grab the Docker Compose. I believe it's open. I think this is the one. Oh, let's go to the 5. Let's grab the Docker Compose and let's go grab that service running. So I'm going to jump back over here. We're going to go to localhost since it's running locally, and I'm going to come in here and let's go create one real quick. Let's just do a simple right? We're just going to create a simple routing account number, right? So that data is displayed, right? There's nothing in here. I'm not displaying back the JWE at all. But let's go take a look at our database real quick. So I'm actually going to read directly from the database in here. All right, and notice in here, notice the structure. This is actually the routing number, right? So this is that's that JWE right here. And so if I come back over here, we're going to go to JSONWebToken.io and I paste this in. Now all of a sudden, this looks just like a JSON Web Token, right? It's the same structure that you see. We have in the header, right? Notice in here, we specifically have that key ID, right? We're using that specific format for key ID. I'm also defining specifically what the encryption algorithm is, as well as what the this is basically the key encryption algorithm, and this is the content encryption algorithm. Their specification defines which one you need to use. You don't need to worry about with our implementation, like we kind of show which one to use and when. This is your actual ciphertext down in here, and then there's some other stuff in here. I believe I can do a base 64. Let's just go do something real quick. Let's drop this in and decode it. Oh wait, I need to grab let's go grab this one part here, decode this, and there should be some other stuff in here as well. I think that's the initialization vector that we have, and there should be another piece out here that should give us the rest of it. There's like 3 different parts in here. That might be the IV, so we have the initialization vector. Then we've got another piece in here. We do base 64 decode. These are probably all. Anyways, so yeah, like what we end up doing when we build this out and we shove all this in here, and we actually create that encryption service, is we're actually populating the structure of that. So we actually define like the initialization vector. This is the authentication tag. So this has information about the AWS encryption, and then additional authentication. This is a base 64 string. Again, we implement this because we're following that JWE specification in there, right? And so on the other side, when you're implementing on the other side and using this, then all you need to do, right, is go on the other side, and basically as long as you have the handlers registered, you should be able to read that back. And our handlers are pretty basic. So in here, when I come in here, all I'm doing is I have my key client. This is very specific to an Azure implementation. AWS, I basically use the Kms Sdk as well. And in here, as long as that we take this encrypted result and we pass back all the pieces, which has the JSON web key, the algorithm, and all the other pieces up here, we can map that into the JWE properly, according to the specification. And then what we do is we take in the JSON web key when we say, hey, I need to decrypt this. All we're doing is really just passing that in, and then we're basically configuring the client, going and decrypting it, and then returning back the plain text so you can read and write. So again, instead of us hand rolling our own, we opted to move towards a specification to do all this. And so by our implementation of using this is now, like we can come along, and if a customer says, hey, I have this proprietary KMS solution, or I'm moving from, I want to use Google Cloud. Let's say we don't have support for that, right? Or I want to, for whatever reason, somebody decides to use Oracle Cloud. Like what we could do is we can simply basically build a handler for that and wire up the code, and the rest of our code in our system does not change at all.
So if you think about, like, again, back to your question, like if you think about as systems grow inside of large organizations, if you start to tell the organization the standard is JWE, the standard is KMIPS, right? Now when you're sending those requests, it could be they pull the data directly out of your database, and then as long as they can talk in the JWE and KMIPS format, they can decrypt that data. And as long as they have access to the keys, they have access to the systems, right? They can get to the data, right? Or to your point, you could be sending requests to other parties and saying, here is our JWE, here's the encrypted data we have, right? If they have access to decrypt that data, they have access to the keys, and they know how to implement that standard, then they can get to that data, right? So it really is starting to create that general communication pattern, right? Just like HTTPS, just like those other systems. If I send you an HTTP request and you don't know what to do with it, right, then you're not going to get information, right? But if you know how to handle that communication protocol, right? So very similar to this. Yep. No matter where you send that JWE, no matter where you send the information, as long as they can understand that format, they can get to the underlying data.
Yeah, so our main driver for this was specification scale, right? Standard scale. right? We've seen that at organizations. Like, I've been like, a good example is like, if you're switching from, let's say, auth 0 to Keycloak, right? Or you're trying to go from Keycloak to that, I don't want to have to go into my systems and make a bunch of changes. I just want to change a few configuration patterns. And the reason why it's so simple to do that is because OpenID Connect and OAuth made that possible, right? They defined a standard. They defined a standard around how you do authentication in systems, right? The same thing happens with common logging frameworks, right? Like moving, let's say, from on-prem, if I'm using Splunk, to all of a sudden I need to do CloudWatch. Like, I don't want to have to go change my system. I just want to go add a new handler within my logging framework, right? And just say, use this one, and I don't change the rest of my code to make that possible, right? Same thing with databases, ORMs. Why'd they become so popular, right? Because I can go and change my dialect, right? I can change my provider. I can go from Postgres on-prem to suddenly using Aurora out in AWS, and I don't change any of my code to adapt to that specific implementation, right? I can go and be multi-database, right, pretty easily with minimal changes to my code. But like, again, going back, I don't see anything like this in the data security world. I don't see anything that says like, this is the definition of what ciphertext key data is. It becomes a universal standard around how do we talk to each other and how do we securely access and share data to be able to solve a lot of the problems, like dynamic key resolution, key size, algorithms, sharing the data without having to fully decrypt it. The driver for this, and I'd love, by the way, any feedback on any of this, is how do we solve this? Because like our system, we have to deal with the most extreme edge cases with the customer demands, right? Like you might have a requirement of, I need to use AWS, you might say I need to use Azure, you might say, hey, I need to use RSA encryption, you might be saying, hey, I need to use double AES, right? Like I want to use split AES encryption, like the key sizes, et cetera. Look, we have to solve for all those edge cases. So like we built something that met our needs because we figured we were the extreme end. And we figured anybody else should be able to implement a much simpler solution through this. So this is literally how we wired this up within our system.
How are you solving, maybe I misunderstood that, but do you need to sign your JWE thing?
Today we aren't signing it because we're the only actor on that data, but there is inside the specification, let's go back to that real quick. Inside here, there's actually a signature part on this that you actually can hook that up. So you actually can do signature. So like for instance, I know where you're going with that is like if you're sharing that ciphertext, right, with the key data, you want to verify that hasn't been tampered with so that way somebody else. Now, that's something that we still are on our roadmap to implement within the open thing, because we realize some people need that. So adding the signature part to this would allow you to say like, yep, it comes from me, right? And then as long as you have access, right, I sign it with my private key, as long as you have access to the public key, you can go verify that that data hasn't been tampered with, so.
And maybe can you explain how did you solve, or how is this solving the rotating key?
Yeah. The main driver for that is coming up inside of here is really leaning into this key ID right here. So key ID is a pretty common thing that specifies like what that key ID needs to look like, right? And it's a standard property of where you put that key ID. That key ID is going to be unique per KMS provider, right? So like for instance, using like an ARN with AWS versus using some sort of like key, URL specific to Azure, right? Those are very different, but using that allows you to be able to go reference that specific key so you know how to look that up. So what we did with the key rotation in here essentially is within our implementation, and I'll jump back over to that, is we'll take a look at this one in here, is we have basically exposed property on here around the key rotation interval, and then down in here, if you sped up the interval in here, when we create that key, what we're essentially doing is setting up the interval down here, basically saying like if it's value, then go ahead and set that when we create that key. So that way when you configure that as part of your options, we'll just automatically handle that key rotation for you. So.
And if a key got compromised, so I guess, even if I have the key, it doesn't really matter because you're constantly changing it.
Yep. And so that's the situation where like why key rotation is so important is like if one key gets compromised, you only have a subset of your data potentially at risk, right? Versus having all your data at risk. And so in the situation of a key getting compromised, you still run the burden of I need to then take that for that key. I still need to go pull that information back and then rotate that key, So, but this should make it a lot simpler to be able to do key rotation as well. So.
Can I ask if you have company already adopting this, or is it very new?
So we've been using this for a better part of about a year and a half now. So we use this on behalf, working with all of our customers. So we opted to take what was internal to our own tokenization solution and pull that code out and then basically open source that. So it is like basically actively being used in a production environment for customers today. So we have all the key rotation stuff actively going. We verified that stuff all works. We've been able to verify like different encryption algorithms, different KMS providers, all that type of solution still works with this. Awesome. So why did we build this? And I think this is answering a lot of the questions that you've already asked, right? We had to solve this on behalf of our customers. Like each of our customers typically has unique requirements, unique needs, right? Key size, key algorithms, like, different KMS provider requirements, et cetera. So we needed a way to basically abstract that away so we weren't making massive changes to our system. Again, we need to customize a lot of this stuff: key rotation policies, key size policies, encryption algorithms, multiple KMS providers. And the thing that we ultimately are running into now is, as we start expanding into net new regions, is data residency requirements, right? So I can't be hard-coded to a single KMS, right? I have to be able to dynamically be able to reach into lots of different KMSs based upon which data region we're actively in, right? Because the data is very localized at that point. So we tried to think about, how do I do hybrid cloud, multi-cloud, data migration, right? One of our customers has an on-prem and cloud situation, so we need to be able to solve for that as well. So that way, how do they be able to transport that data while still be able to decrypt it when it moves into a new ecosystem or a new environment? I'm kind of curious, it seems like you've ran into a lot of these problems, but I'm also kind of curious, if anybody has additional things that they've ran into with encryption, right? We love feedback on this type of stuff. We always look for different ways to make stuff better. I think at least stuff that I can think of off the top of my head that I've ran into that's driven massive changes is sharing sensitive data, right? With, very boutique encryption solutions on per app. The only way that I've typically seen is somebody either has to re-implement it in app number 2, or guess what? That data gets decrypted, shared in plain text from system to system, and somebody inevitably is going to forget to delete the file, or somebody's inevitably going to not encrypt it, or something like that, and that generally creates a massive problem. Multi-cloud, hybrid cloud environments, right? Different KMSs ultimately do that. Go to cloud migrations is a massive one I've seen before, where it's like, how do I go from on-prem, my data lives here, and then ultimately get that in the cloud while still making it accessible? So, not having to do bulk data decryption and figure out how do I migrate that data. I just want to be able to copy it and then have it be referential so I can go decrypt it. As we saw, changing security and compliance requirements, key rotation challenges. I mean, these are some of the stuff I've personally seen. I don't know if anybody's seen any other things that has driven your encryption or security posture changes.
One of the things we deal with is our product people want search on data that's encrypted. And we have some solutions for that, but that's a pretty constant friction.
Yeah. So we actually solved that within our solution. I'll talk about exactly how we solved it. So there's kind of a couple options you have at play. So one that's kind of up and coming that a lot of people are starting to look at is homomorphic encryption, right? And that's something that the problem is homomorphic encryption has a pretty big overhead tax on how long it takes to actually do searching over that encrypted data, right? I mean, you're talking an order of magnitude slower than if you were to even just decrypt the data or alternative approaches. So one approach that we took is what we call we create something called blind indexes. Yeah, so blind indexes. So the problem that we ran into is we didn't want to just on behalf of our customer specify here is what you want to search on. So what we use, and I'll show you how we actually solved it. And I don't mind sharing any of this stuff with you. So the way that we do it, hopefully the internet actually works here. Man, this is speedy. So I was going to say the way that we solved it with our stuff, and this is a little bit of an insertion, so we'll talk about search down in here. So the way we did it, most of you probably are familiar with something like liquid templating, right? If you've used like Shopify or Mustache or Handlebars or any of that type of stuff. The problem that we ran into is like, we didn't want to go to our customers and say like, you can only search over the data like last for, or you can only search over it specifically, because like those business requirements change all the time, right? And so the way that we did it is like basically allows you to define these expressions to say exactly what I want to select, and then how do I want to transform that data so I can make it searchable across the different things. Because more than likely those searching is usually driven by some sort of like business requirements. Like, hey, I need to find all accounts where they're in a specific zip code, or I need to find all accounts that end in a certain email domain, or I want to find things that have like a certain routing number, the last four of a credit card, or I want to look up credit cards by BIN information, right, and that type of stuff. And so the driver for this is like you can define those and update that, and then behind the scenes what we do is while we have that data still in plain text, we basically run these expressions over it and we generate basically that, and then we cryptographically hash that. So when you perform a search against that data, we take that value in, we cryptographically hash it, and then we compare against the hashes. So that way we get really fast lookups over that sensitive data. So that is one approach. Again, the other approach that's prevailing coming up is using homomorphic encryption. There's a variety of different types there. That also works, but you're probably not going to want to use that for like transactional type situations where you need really, really, really fast feedback loops. That works a lot better when you're dealing with things like logging, or you're dealing with like analytics type systems, like if you're using like Snowflake or something like that, because typically you're generating a report, and if that report takes longer to load, typically that might be okay. But again, instead of talking like millisecond times, you're talking like times in like minutes to get a response back on homomorphic encryption. So that's another option you have at your disposal as well. Yeah.
So when you talk about hashing, are you salting those hashes? And then what do you, I imagine at some point you need to salt, change that salt, right?
Yeah, so basically the way that that's set up is the only way to really regenerate it essentially is you have to read back the data and regenerate those, right? But we use a salt and pepper approach, right? So that way we ensure that there's enough entropy in that. So that way if like, for instance, if you and I had the same record, right, we're gonna get completely different cryptographic hashes. So that's very unique to us. So obviously you don't wanna use like a common key when you do that. So you wanna make sure you have enough entropy in that process, so yeah. So we salt and pepper all of our stuff. So there's the salt at the customer basis, and there's the pepper, right, more of a global on per deployed instance that allows us to have enough entropy in that. So that way, even if one system gets compromised for one customer, it's going to be very different than a different system for a different customer.
But
so
you cycle the salts and then decrypt and then rehash.
Yeah, but that would have to happen asynchronously. So
you do that out of sync.
Yeah, out of sync. You wouldn't want to do that typically because it's going to be very similar. Like if you were to re-index, let's say a Lucene or Elasticsearch database, right? Like you're going to have to rebuild that index by reprocessing all the data, and the same problem happens there. So that's why you try to do that on like specific customers, right, and small subset of the data, right, or a subset of what you care about. So that way you're not having to do it for all your data all at once. So.
Is there any technique that works on a partial search? So like I might want to search customers, and, kind of as I type, kind of style searching versus an entire email or something.
Yeah, and we haven't really found anything out there that really does that well. That's still like a massive gap typically when you're dealing with like lots of encrypted data. So it's like there's some advancements in like the homomorphic encryption stuff that does that, but there's not really like fuzzy search operators or like things with boosting and that type of stuff that most of us would probably expect. But that's kind of like one of the negatives, like with some of the sensitive data and the compliance stuff. So.
Yeah, and a lot of what we see our customers and other people in the industry do is like, depending on how sensitive that information is, they'll just mask the first 3 characters. That way they can provide that faster feedback loop without exposing the entire organization to that risk. So that way, once you get to 3, if you can't find what you need, then you're doing a more like standard lookup. Hey, give us 5, give us 3, give us whatever that is. So.
Yeah. So if you can search on like a few, at least then if you had to like do bulk decryption, at least it's a much smaller subset than all of your data or something like that. So.
Plugging to BI tools, I think would be interesting. How it is that you can you have those handlers as like plugins into the API. So you
Yeah.
don't have to do it.
Yeah, and that's definitely like we've actually been like having conversations with like some of the companies like Snowflake and Databricks and things like that, trying to move towards something more native. It'd be nice if like it would be really great is if not even have to make any code changes, right? Like moving closer to the actual database provider level or moving closer to the KMS so they support this more natively. So that way you're not actually have to go implement anything in your code. That would be ultimately where I would love to see it, which is like I have the option to say, hey, AWS KMS, I need to encrypt this data, and it sends me back this in the specified format, right? So if I need to move that into a BI tool, and the BI tool can also implement with that dialect or whatever, it can natively decrypt it, and my code doesn't change in that situation. I'm just moving those JWEs around between systems. That would be the dream, right? But obviously, like, we're taking the first step, which is make it easier to consume for engineers, right? Like, focus on that developer experience, so. Awesome. Cool. I think we're just about at time. I think we've got less than 5 minutes left. So I'll throw up the thank you slide, obviously. By the way, I love feedback. I'm super passionate about this problem. I've been doing this for 20 plus years, right? Again, going from military days all the way to where we're at. I've loved data security. I love working on this stuff. I love solving this. And at the heart of all of this, and this is a core tenet of how I believe this, is data security I don't think is still a technology problem. I think it's a developer experience problem, right? At the end of the day, because there's not a lot of great tools out there, there's not a lot of great implementation, there's not a lot of good patterns that show us what to do, and becomes a why not problem versus why do I need to do this. There's a lot of friction to get adoption, right? So I'm constantly thinking about how do I make this as simple as possible for the average engineer? Because the average engineer, again, they are not security experts, right? They typically are like, I'm doing the bare minimum to get going. But how do we make the bare minimum still be flexible, extensible, and still be future-proof for these organizations? So I'm constantly thinking about that problem. I'd love feedback, by the way. I'd love for anybody to poke around, tear it apart, give me feedback, reach out. I'd love to hop on a Zoom call, dig deeper. I'd love to know your company's problem and figure out like how can I just give you my experience and say this is how I would solve it, right? I'd love to give that feedback. I love this problem. This is a space I've been in for so long, and I want to make these problems go away for the average engineer. Any questions? Anybody? No? Yeah.
I have one. Have you, there's something that's starting to emerge out of the mist, which is almost like a philosophical difference and stuff, but ITS, information theoretic security, where it's basically the concept is encryption by implication that the data set is locked, and it needs to be unlocked somehow with a key. Information theoretic security does not do that. It basically takes the secret, shreds it, and it's forward moving, and it cannot ever be reassembled back to the original secret. There's a company called Million that is emerging out of academia that's starting to look at that, which gets rid of keys completely.
Oh, interesting.
Still fairly early on, but I didn't know if it had shown up on your radar yet.
Yeah, we've seen a couple of companies like advertise like passwordless security or keyless security type
It's almost
stuff.
like a zero trust type.
Yeah, type stuff. And we're
That's still, this still is kind of like, hey, we want to get rid of keys completely.
yeah.
So we just basically shred it, and then actually they can compute on the particles, without having, and they can't be reassembled. It has to be, it's always forward moving.
Interesting.
So you can't move backward on it.
I'm sure Adam already is like looking it up, and and by next Monday he's probably already gonna have a prototype built on it type things.
Kind of like Million, but with an
Oh, awesome. Yeah, we'll have to take a look and dig into some of that a little bit. So that definitely sounds like a very emerging type stuff. So
I mean, it's years away, so job security is fine.
yeah, I think what's going to be really interesting is going to be like, they're talking like by 2032, basically with these like post-quantum encryption type algorithms coming out and all that type of stuff. Like, I'm wondering where these companies are going to be at, right? We're going to see organizations that are going to be looking at massive changes to the way that they handle encryption, the massive changes to the way they handle keys. The algorithms are going to be changing, right? And how do you do that without, and so these companies are going to be in this spot, right, where it's going to be like, they're going to just accept the risk, just say, yep, RSA, 2048 or 4096 is good enough, and we're just fine. Like it's better than nothing. Or they're going to look at patterns to get to that, but then they're going to realize the technical debt, right, the security debt that's going to bleed into literally every single one of their systems, right? And so the reason why we did this approach with the policy or the scheme approach was like, how do we also start thinking about like realizing that like this is going to change, right? Within literally the next 10 years or less. How do we start pushing towards something that like, hey, when that changes, all I literally have to do, register my algorithm, define my policy, and go. I can still decrypt my existing data if I need to, and then behind the scenes is I can go re-encrypt all that data without eating an outage, without taking that down. And it provides that faster path to adoption there. And so like I'm just constantly thinking about like how do we get people moving in that direction, because it's coming. I mean, like we're less than 10 years out. They're talking what, like 2028 I think is mostly going to be like inefficient, and then by 2032 I think they're talking like completely obsolete. And so NIST is just now getting ahead of it, and they're trying to get FIPS adoption and all that type of stuff. So that way, because most companies that are under compliance are going to be required to be NIST and FIPS type compliant implementations. So
well, they're starting to figure out, okay, what crosses the threshold, and I only want the minimum that I need.
yes,
The threshold is kind of malleable, right?
yeah,
Because we're seeing this with zero knowledge proofs, to where it's like, is this enough to cross the threshold?
yep,
I can't show you the secret, but I can show you a mathematical proof that my secret matches yours.
yep,
So, does that cross the threshold?
yep.
So, for GDPR, it does not right now, but that's more of a governance.
Mm-hmm. Yeah. Well, you're going to start seeing that probably in other regions that are getting more aggressive, right? Like India's showing some pretty aggressive stuff, Brazil, et cetera. Like we're starting to see a lot stricter requirements coming out of those countries than we even saw with GDPR coming out of the EU with some of the compliance stuff. So I imagine some of those requirements are going to come sooner than later too. And it's going to be really interesting too. Like we're going to run into problems with like, well, okay, cool, we got all this PII data encrypted, right? But what do you do when all of a sudden CCPA turns into, guess what, there's 50 implementations because every state wants their own equivalent of CCPA, right to be forgotten. But if that data is all sitting encrypted, how do I actually get access to that information, right? How do I meet those compliance while still keeping my data secure? Because now all of a sudden I'm gonna need a way to be able to go find those records. So then you're gonna run this problem of like, well, I think somebody asked like, how do I search over the data, right? I think you were asking that. It's like, well, I need a way to be able to look up without decrypting all that data, but I still need to meet these requirements. So the companies are gonna like, well, do I eat the risk, right? Or do I look at other solutions to help me solve that problem? So and I think that's coming sooner than later too.
Well, you're starting to see with trusted execution environments to where you've got some organizations like telcos specifically that have these enormous data lakes that they cannot give up custody, but it's very valuable data. They want to monetize it somehow, and so they will set up a trusted execution environment to allow people, so if you can have real-time location or movement data that you cannot put on a Snowflake or an Informatica
Yeah.
type thing. That they're saying, how can we allow someone within a trusted execution environment?
Yep, and you're starting to see some of that come cloud native too. Like AWS has their enclave stuff and things like that are starting to emerge.
Has conclave.
Yeah.
It's all
Yeah, so they're all starting to emerge, providing that so you can like cross over. Like that's something else that we had to solve too. Like we've got the equivalent to like AWS Lambdas that basically like you write your code, run it. You don't ever have access to the data, but you can still compute over it without ever like getting access. So doing some of that like lookups and searches and processing without ever exposing that data. Like that was a problem we had to solve because like we have companies like customers are like, I do file processing. Like I need to go reach out to like JP Morgan Chase lockbox file and download a file and process all that and generate ACH transactions. Like, what do? I don't want that processing through my system, right? So that was like one of our early problems we had to solve was like building basically a TDE type environment. So.
Or I just want some type of data to feed into my AI ML engine.
Yeah,
Right.
exactly. So go generate hashes because all I care about is heuristical data. I don't actually need the original value. I'm just looking at patterns, which is really a driver for ML. So like, those hashing, right, that helps tremendously on that. Generate the hashes, put them in there, and then all you're doing is looking for patterns over the hashes. So,
But you would need a bulletin board of some type to store the hashes or something.
yeah,
So you can reference back and forth. And as far as compliance reporting, you got to be able to say, hey, here's the hash.
yep,
Chain of custody.
awesome. Well, I think we're less than a minute left, so if there are any questions, concerns, thoughts, comments, jokes, by the way, I appreciate all of them. By the way, I love dad jokes. I've been telling a lot of people lately about dried raisins. I think it's all about raisin awareness. Or dried grapes, all about raisin awareness. I have plenty more, so if you want more, again, reach out. I'll talk about encryption, I'll talk about dad jokes, either or. So.
All right.
But awesome. I appreciate it. Thanks so much.